power series. Okay, now what is a power series? First of all, it must be a power. It must have power. And secondly, it's a series. Okay. Now a series is what? It's a sum of infinitely many terms. Okay. So it has two. It has the following two forms. One it looks like this. I'm using the notation in the book. Okay. A k x k, k from 0 to infinity, or summation k from 0 to infinity. I'm sorry, they use C, so I use C. So ck x minus a to the k. Okay? It has two forms. Each one of these is a power series. This is power series centered at 0. This is power series centered at 0, because it's x is really x minus 0. And this is power series centered at a, because it's a, okay? And this is at 0. Both of these are power series, power series, power series. They are all powers, as you can see, they are powers. And they are series with infinite sum. So they are called power series. Now, power series is very important in the application. Okay. For example, you have calculator, right? I'll explain certain things, and I'll tell you where. In the calculator, there's a place we use this. Okay, but I'm going to. I'll leave it when I'm talking about that. Okay. So anyway, so this is 9.1, section 9.1. Talking about something called power series. Okay. So we want to. So we have it. So the question right now is, if I have a function. So given a function. Okay, so say f of x, and the a and the number a, and the a number a. Okay, we want to represent f of x as a power series. Of, say, of these two forms. Okay, I want to express it like this. And know that 1 is just a simple case. 1 is a special case of 2 when a is 0. Okay, this is a very special case of 2 for a equal to 0. All right, so how do I do this? So this says, how do I express this? Okay, how do I do it? Well, so the way to do is this following. Okay, so suppose I have f of x is equal to this. Okay, suppose, and I want to find out what ck are. We want to find out what ck are. Okay, that's what we want to find. All right, so how about let me write it out. So when k equal to 0, I have c0, right? And 0, so it's 1, plus c1, x minus a, plus c2, right? X minus a squared. And so on, okay? And the nth term, right? So this is really equal to this. Okay, I write it out. Okay, now I'm going to do the following. I'm going to let x to be a on both sides. Now what happens if I let x to be a on both sides? Well, I have f of a, right? Equal to c sub 0. Well, if x equal to a, all these are 0. All those are gone. 0, 0, 0, gone, right? So the c sub 0 must be f of a. All right. Now if I take another derivative, so I'm going to take derivative, okay? Take f prime of x, derivative. Then I have f prime of x, right? C sub 0 is a constant, derivative of constant is 0. Derivative of this, well, so we derivative of this, right? What? With c1 plus 2c2 x minus a, right? Plus, and this will be n cn x minus a to the n minus 1 and so on. Now, if I let x to be a again, what happened? All those, except the first term, all the others are gone. Because x, if x is a, this 0, 0, 0, everyone is 0. Only the first term survives. So f prime of a is c1. Okay, so right now I already found out what c sub 0 and c sub 1 should be. C sub 0 is f of a, c sub 1 is f prime of a. Alright, then I can continue doing this. So let me just write one more term. Okay, write one more term. So I'm going to take the second derivative of x. I'm going to take the second derivative of x. Okay, so this is equal to what? If I look at this expression, right? Second derivative, c1 is gone. This guy, well, so 2c2, right? 2c2 plus n times n minus 1 cn x minus a to n minus 2. Well, if I let x to be a again, what happened? Well, f double prime of a is 2c2. All the rates are gone because all rates has x minus a, so they are all gone. So c2 I found is 1/2 of f double prime of a. Okay. Well, in fact, I'm not going to do too many. So in fact, you can check Cn is equal to n factorial. F differentiates n times, and you substitute x by a. In fact, this is the general formula. In fact, for all n, this is general formula. Okay. All right. Now we're going to define. We're going to define two terms. One is called Taylor polynomial, and later on we'll talk about Taylor series. Okay. So Taylor polynomial. If this definition, right? Taylor polynomial. So given a function f of x. Okay. I just use a definition in the book so that it will be easier for you to find. And the point A, the Taylor series, the Taylor polynomial, okay? Taylor polynomial of nth order is at with the center, okay? With the center A is this definition, okay, is defined to be all the way to C sub n. So it's C, so it's F, so it's summation C ck x minus a to the k, where k is from 0 to n. Only go all the way to n. It's nth order, so we go all the way to n. Okay? And where the c sub k is the one we found. Okay, this is called Taylor polynomial. Okay. Taylor polynomial of nth order at the center A is given by this, where ck is equal to this. And this is on page 664. That's the definition. Okay, so if you have the book, you can look at page 664. All right, so in this section, 9.1, you see, if you look at title, is approximating functions with polynomial. So we want to approximate a function with a polynomial. We want to approximate a function with a polynomial. So in other words, what we are doing in 9.1, so this is 2. 1, this is 2. Right? So what we want to do in this, in 9.1, what we want to approximate a function f of x with the center. This center will be given to begin with by its Taylor polynomial. Okay, so go by nth order polynomial. Nth order Taylor polynomial. That's what we want. That's what we are doing. N can be 1, 2, 3, 4, 5, 6, can be any number, but n is a finite number. So I have an f of x, and I want to approximate f of x by this one. I want to approximate by the Taylor polynomial. Yeah, nth order Taylor polynomial. So by this ck x minus a to the k from 0 to n, where c sub k is f differential k times a k factorial. Okay, so in other words, f of x is approximately this. Okay. Now we need to know the error, because this is only approximation. So there's an error. Error in the approximation. Now there's a nice formula given. So I'm just going to copy it down, okay? Let me see where it is. There's a nice formula given. Here. So anyway, so I'm going to call this guy so that P, let me just use the notation, okay? That P sub n of x to be this guy. Then the arrow, right? The arrow is f of x minus Pn of x. That's the arrow. This arrow is, this is my function, and we want to approximate this by this one. So the difference of these two is the arrow. So that's the arrow. Now what is the arrow? Okay, there's a nice formula.